Hey guys, welcome to this new episode on solution architectures. So I'm planning to create this new series on solution architecture, especially to address different problems that you might come across in your existing architectures and how we can provide some solutions. So I'm going to discuss several solution architectures. In this particular episode, I will be mainly discussing about this uploading large payload issues and how we can fix it. So the main idea here is to discuss the problem, what is the problem, and how we can actually then mitigate this problem or solve it. And also, I will be giving you some implementation guide on how to do this as well. So let's start with our first architecture, that is uploading large payloads. Now, this is the problem. For the most parts in modern applications, if you are like building a serverless web application, there is this classic architecture that most of us are very familiar with. So you have your client and client is sending request to an API gateway. So this API gateway then triggers an Lambda. So this is the Lambda that have some business logic. So it may like talk to a database, maybe talk to a third-party service and so on. And once the response is there, it will be returned back to the API gateway and it will be forwarded back to the client. So this is a very classic way of implementing your REST APIs. And probably you already are using this type of a serverless architecture. Now there is an issue when it comes to uploading large payloads. Now the very first issue is that the API gateway has an payload limit. Now, API gateway supports only up to 10 megabytes of data. So if your payloads that is passing from the client is more than 10 megabytes, then it's going to send an error, okay? Because the maximum limit is 10 MB. And in the same time, the Lambda also have a payload limit of 6 MB for synchronous invocation. Now, API gateway is synchronously invoking Lambda. So there, the payload that is passed from API gateway to Lambda must be less than 6 megabytes. So even if your payload is 6 MB, right? So then the API gateway will allow it, but at Lambda it will be rejected and send back an exception. But sometimes your client might want to send larger payloads. So it could be an image that you want to upload, or it could be a JSON payload, maybe a bulk upload that you want to do through the API gateway. So in this case, there's a problem. So what is the solution? So the solution is basically using a different route to upload that large payload. Right? Can you see now up here we have our normal API gateway, Lambda, and the database, the classic architecture. But if we have some large payload, what we are going to do basically here is to upload that large payload onto S3 bucket, right? And that will happen synchronously. And after that, the S3 bucket will trigger an event. Now, S3 bucket, we can configure it to trigger an event as soon as an object is added to the bucket, or it could be deleted. The different events can be added depending upon the action of the object. So in this case, we can trigger an event as soon as an object is added. So we can trigger an event, and this event is, it is asynchronously invoking a Lambda function. Now, S3 bucket can trigger a different service as well, like a SNS, or it can call another SQS queue as well. But in this case, what we are triggering here is another Lambda function. So this event that is triggered from the S3 bucket will send you some metadata information about that uploaded object. So it is going to send the S3 bucket name as well as that particular object key. So with that information, Lambda can actually query the actual object, right? And then get that information here in the Lambda. And now our Lambda has that full payload. So we don't have any limit issues here because none of the payloads that is being passed to the Lambda is exceeding 6 MB, because here S3 bucket will only send an event with the metadata, and the metadata is like only few kilobytes or bytes. Now that Lambda can query the actual data, this Lambda function can perform the business logic, and the final result can be either uploaded to a database, or it can call a different other function. It can actually complete the execution of that particular payload. Right? Now, there's another element I'm added here, so that is SNS. So SNS is added as a Lambda destination. Now, why do we actually need a Lambda destination here? Now, the reason here is, since this is an asynchronous invocation, this request is no longer waiting for the response. So the synchronous part ended as soon as the large payload is uploaded to the S3. So the S3 will send another response, okay, it has been uploaded, so that's it. So the request response circle is completed. But what if we want to like convey back to the client once the asynchronously invoked Lambda process is completed? So that is where we can use the Lambda destination, which was introduced quite lately. So the Lambda destination is basically you can tell Lambda uh, to invoke another service. So it could be SNS. So it could be another Lambda function. It could be a SQSQ, right? As soon as this processing is done. So as soon as this is successfully completed, we can ask Lambda to execute another service. Or if any exception is being thrown in the Lambda, we can have another destination, a failure destination, in order to convey that information back to the client. So in this case, what I'm doing here is to invoke an SNS topic that will send an email to the client that the execution is successful. Now, if we look at the description here, upload to S3, that's fine, using an S3 pre-signed URL. So why do we actually need a pre-signed URL? Can't we just directly upload to S3? Yeah, of course you can directly upload to S3 if you configure the S3 bucket with public permission. So that means anyone can upload into this S3 bucket. If you configure it in that way, you wouldn't need a public pre-signed URL rather. But that is a security issue because anyone in the internet can upload to S3 bucket. So we need to block this public access. So that's what we need, some permission to be checked when uploading from the client. So that's why we are going to create a pre-signed URL, and this pre-signed URL is generated through another Lambda function that is invoked from the API gateway. So the process is happening like this. So if a client want to upload a large object, what he will first do here, he will request for a pre-signed URL. So there will be a method that is added in the API gateway to get pre-signed URL, and that will call a Lambda function. So the Lambda function will generate a pre-signed URL for the S3 bucket that is defined, and then it will send back to the client. So that S3 pre-signed URL will be later used to upload that particular large object. Now this pre-signed URL will consist of some temporary credential, and also there will be expiration time for this pre-signed URL. So in this case, we will define it as 5 minutes. After 5 minutes, this pre-signed URL is no longer valid. So even the client cannot use it after 5 minutes. Now, can we do that in a different way? Of course we can. Now, instead of a pre-signed URL, we can actually use IAM credentials. Now, if this client is being authenticated through Cognito service, the Cognito service probably will pass some temporary IAM credential onto client. So we can actually use those IAM temporary credential to call upon the S3 SDK and send that large payload. But the scenario that we are currently discussing is that they have only this classic architecture earlier, serverless architecture, and all the authorization aspect of the user happening at the API gateway. So it could be a Cognito authorizer, or it could be a Lambda authorizer. So that will handle some custom logic to identify the user. Maybe depending upon his role, he will be assigned some permissions. So in this case, there will be a JWT token that will be passed back and forth to the API gateway, and from API gateway to the Lambda, right? But the client will not have this temporary IAM credential. So in that kind of a scenario, what we can do here is to obtain and pre-sign URL from a Lambda function that has this particular token already verified with API gateway. So that's why we are generating the pre-sign URL here and send it back to the client, because API gateway knows the authenticity and the permission the client has. So in this solution, we have two Lambda function. So one Lambda function is responsible for generating that pre-signed URL, and the other Lambda function, which is invoked asynchronously through S3 bucket, will have the code to execute that payload. Now, one other thing is, guys, in AWS, there are multiple ways to implement a solution for a certain problem. So this is one of the ways that I decided to share with you. So if you have a different architecture in mind, please share it in the comment section so we can all share the knowledge. Okay, so this is the diagram. Now let's go ahead and implement it. Now I've created a GitHub repository. So this GitHub repository, it will contain all the code. So if you want to get the code, just copy the URL and do a git clone into your text editor. Right. Now, once you do a git clone, you will see there's one folder and one file. This is index.html. Now, this index.html is our front end basically. Now, I'm not using any framework also because this is a very small UI and I wouldn't need to have that all complexity there. So let me show you what is there in the front end. So it is nothing but just a button, right? It says upload large payload. Now this is that particular button here. And in this button, I have this on-click event handler. So there is this upload function get triggered when someone click on it. So now this is the upload function. Now you can see it is within the script tag, so I can run any JavaScript here. So this upload function does a couple of things. In the first line, it is going to grab some large payload because our idea is to upload some large payload. So what I'm going to do is I'm going to query the to-dos endpoint from a dummy API called JSON placeholder. So there I'm going to query all the to-dos. So I think it's going to return me about 200 to-dos, but still not it's very large, but just assume this is a very large payload. And once I have that large payload, then I need to upload it to S3. Now before uploading it that, I need to get an signed S3 URL. So in the second function, I'm going to get that signed URL. So in order to get the signed URL, my client will call this Lambda function through the API gateway. So it is going to use this API endpoint and call that Lambda and get the signed URL. It is now going to upload to S3. So now it is directly going to upload to S3 using HTTP POST request. So I'm going to use fetch API here. So I will get the signed URL and I have the payload, and then I will use fetch API to do a put operation into the S3 bucket. So as soon as that object is uploaded to S3, then this Lambda function will get triggered. So let's look at the code for these two Lambda function. So that code is available inside the API folder. Now in this API folder, I'm using serverless framework, right? So in this serverless framework, I have these two Lambda functions defined. Now this is the get signed URL Lambda function, and this is the execute payload Lambda function. Now you can see get signed URL. I have attached an API gateway. Now this HTTP event creates an API gateway, and I am adding this particular path onto the API gateway S3 URL so that it will trigger this get signed URL Lambda. But the execute payload Lambda function is not creating an API gateway. Do you see? It's not HTTP event, but it's a S3. So this is going to create a trigger onto this particular S3 bucket. In this case, I call it my-youtube-uploads. You might have to use a different name here because it has to be unique. All these three bucket names has to be unique. And then it is looking at the event of object created. So this is basically when an object is added to the S3 bucket, and that is the event which will invoke this execute payload Lambda function. Okay, now let's look at the get signed URL code. You can see it is in the handler folder or file rather. I will go to handler and there we have it. So it's a very small code. So first what I'm going to do here is I'm going to reference the bucket that I want to generate a signed URL for. So I'm going to generate a signed URL to this particular bucket, the same bucket, and I'm going to create a key or the object key for whatever the payload that I'm uploading to this particular bucket through the signed URL. So that key is a unique ID in this case. So I have a GUID here, and then I'm defining the expiration seconds. So in this case, 16 to 5 seconds, that means 300 seconds, that means 5 minutes. So after 5 minutes, this signed URL will be expired. Now another important thing is, for what am I creating this signed URL for? So that is basically in order to put an object, right? So this signed URL will be designated to put object. So you can't use this to get object. So if you want to create a get object, then this action has to be changed to get object. But this case, I only want to put it into S3 bucket. So the action is put object. And then I'm defining the parameters here. So the bucket that I referenced here, and the key, and also the expiration seconds, and then the content type. Now, don't forget this one, because if you forget this one, there will be a problem when you are calling it from the front end. So this content type has to be exactly the same, right? So in this case, since I'm uploading JSON, it is application/JSON. And as the return value, I will send the status code 200, and I'm going to send in the URL that is being generated to me. Now I'm using ES6 object destructuring here. So the front end will get the URL. Now once it got the URL, it is going to directly use the fetch API and upload the content to S3 bucket. And once it is added, then this Lambda function get triggered. So it is the second Lambda function, that is execute payload. So what is happening here is, like, it is getting the metadata from the event that is passed onto S3, because there's an event get passed, and that event will contain some metadata. So that metadata, it will contain the bucket name and the key, right? You see, I get the S3 event from event.records and S3, and in that particular event, it will have the bucket name and the key. So I have these parameters. Now what I'm going to do here is, I'm going to actually query the large object. So again, I'm using AWS S3 SDK. You see up here, I'm referencing it using AWS SDK. And I'm going to call s3.getObject, and I'll pass this parameter bucket and the key. And I'm calling the function with the promise at the end in order to return the response as a promise. So I can await it to get the actual data. So once I got the actual data, then I'm going to go into the body and make it toString, and then do a JSON parsing. And finally, I got the actual data here. Then I'm doing a console log here, so we can look at the CloudWatch logs. And after this, you can execute whatever your business logics. Now, in order to execute these Lambda functions properly, we need to provide some permissions. So let's go to serverless.yaml file. And in IAM role statement, I have given 3 permissions. So first permission is put object. Now this put object is required in order to generate an sign URL. Because when you are generating a sign URL from AWS Lambda function, first of all, this Lambda function should be able to put an object into S3. If it is unable to put an object, then that pre-signed URL will also be unable to do that, because the pre-signed URLs is assuming the permission of whoever creating that pre-signed URL. So in this case, our Lambda, so it has to have this put object permission. Then this particular IAM role will be shared among both of these functions. So that's why I added this get object into the same IAM role as well. Or maybe like you can create couple of IAM roles, but for simplicity, I have just single IAM role. So I added get object permission into the same IAM role. So my execution Lambda can call this S3 bucket with the metadata and obtain the actual large object. And finally, I have given this SNS publish permission. So this is nothing but for our Lambda destination. So once this is successfully executed, we define a on success execution. So that is a SNS topic. So that SNS topic has a subscriber to send an email back to the client. So I'll show you in a bit. Now, in order for AWS Lambda to push a message to SNS, it should have SNS publish permission. So that's what we have here. Now, let me show you that SNS topic. Now, if I go to SNS and I went to topics, and do you see there's a topic called upload success. So this is the ARN I have referred here, right here under the destination section. Now make sure that you have the latest serverless versions because this was recently added to the serverless framework as well. So now you can have a separate section for destination. Then you can define on success and also on failure destinations. So I'm here only using on success. I'm sending the message to that SNS topic. So this SNS topic has a subscriber. So for now I have added my email address and this is the protocol of email. So it's going to send me an email as soon as this processing is successful. Okay, now let's have a look at the front-end code real quick. So up top I have my API gateway URL. So this is basically to generate a sign URL. And then I have this to-dos endpoint. So this is basically to get the large payload. So my upload function first get the to-dos, right? Let me expand this to-dos. So it's using the fetch API, to-dos endpoints, and it will return the full to-dos list. And then I'm going to call upon get sign URL function. So if I expand it, so it's going to call upon this API gateway endpoint, and then it will return the data. Do you remember? Now it is going to return the sign URL along with the data. So now I have the data here. So in data, there's attribute called data.url. So that will have the sign URL. And also I'm passing the to-dos that I earlier collected to this function called upload to S3. So let's expand that function as well. So in this upload to S3, again, I'm using fetch API. Now this is our sign URL, right? So now we are going to this uploading part. So we are using the method put, and this is the place you must not forget the content type has to be matching with the content type of the sign URL generation. Otherwise, there will be a error, a signature mismatch error. And then as the body, I'm passing this to-dos. Again, I'm using object destructuring here. You can just use to-dos like this. Now let's test this whole flow. I will get the URL, get the data from the to-dos, and upload with the signed URL. And let's see if this function get executed. And we'll look at the logs of the CloudWatch if so. And also I should receive an email. Okay, now here I am at the front end. So I'm gonna call this upload payload. You see first it's going to get the to-dos, right? If I open it up, so it has like 200 odd to-dos, and then it's gonna call S3 URL, right? So this is going to call my API gateway endpoint that I previously created, and it's going to return me the URL. So you see it's a very long URL. The whole thing is the URL. This is a signed URL, so that's why. So it has this credential built into it. Do you see AWS Access Key ID and the expiration and also the token, right? So this token is going to expire in 5 minutes. And after that, we are using that signed URL. Do you see this large signed URL? And I'm going to send the to-dos payload along with that. Do you see this to-do big payload? So if it is successfully uploaded, I should receive an email. Let's check my email. There you go. I got the upload success email. Very nice. So that means it has been properly executed in my Lambda function. So let me quickly check that as well. I will go to AWS Lambda and I will go to execute payload Lambda function, right? And there I will go to monitoring section. Now you can easily go to your function and then search for execute payload. Then you will find this. Let me show you quickly. Go to AWS Lambda and function, just search for this, hit enter. This is your function. Click onto that and go to monitoring section. Then you will see view logs in CloudWatch. Click onto that. Then I should see a log message in there. There you go. Because if you can remember, in our handler function execute payload, we are finally console logging the result. There we have it, and let's open it up. And I should now see that to-dos. Like you see, it's to-dos, and it is this big object. Perfect. Okay, now one last thing I want to tell you guys. The S3 bucket that get created, let's say in this case my YouTube uploads by serverless framework itself, we need to add some cross-origin request configuration. Otherwise, our local host, so in this case I'm using my domain as my local host, so it cannot like do this final put REST call into the S3 bucket. So in order to do that, go to your S3. So I will go to services and search for S3 and search for it. There we go. Open it up and go to permissions. This and go to cross configuration, and you need to add the cross configuration. You can find it if you go to documentation here. Scroll a little bit down. There you have an example. Just copy this whole thing and paste it here, and then keep only one cross rule and make sure to add your origin here. So in this case, I'm whitelisting my local host 5500, and I'm whitelisting all the methods as well, get, put, post, delete, although you might not need to. And I'm whitelisting all the headers as well. Yeah. So do that, otherwise you will get some cross error. So we enable cross in the S3 bucket, as well as we have enabled cross at our API gateway level. You see, so this function is attached to API gateway. So I am enabling cross for this particular get method as well, which has this S3 URL. Okay, so this is what I want to show you guys. I hope it has been useful. So if you like these videos, please subscribe, like, and share with your friends. And I'll see you in another one. Thanks.